Hello, this is Could an Open Lab seminar on the November 12th, 2025. And today it's our greatest pleasure to have Christian Bentz, who's from the University of Saarland. And he's also actually the PI of a ERC grant, which just started, which will actually deal with mostly Paleolithic sign systems. And today he will speak about statistical properties of a 40,000-year-old sign system. I'm particularly excited about this because I've taught a course in the past where when I have 49 objects, like 49 talks, 49 students, I sample from the exponential distribution of human productivity as it is documented in artifacts. And that means you get one object before sort of like 5,000 years ago. And obviously, it's rather rare to actually encounter that, but making a point in this particular session that this also belongs to cultural data analytics. And obviously, you could go further back. But one of the core issues is that 40,000 years ago is sort of a time that is typically forgotten in the, let's say, computational social science dealing with pictures from Flickr and posts on whatever was Twitter. Chris Bentz, the stage is yours.
Thank you very much, Maximilian, and also Mikhail, I think, who invited me, yes. And I think we met in Siena at the conference for complex systems. So that was a great conference. And that's the reason why I'm here. So again, thank you very much for the invitation. I would like to split it. Maybe I will talk for 40 minutes with my slides, and then we can have open discussions. Right, so I would argue that what distinguishes us as humans from other animals is that
Chris, can I have one question? Can you show the title slide at least for a few seconds? So I actually can, yes, thank you. Thank you.
Is that okay?
Yes.
Okay, good. Yeah, I would argue that what distinguishes us as humans from animals, other animals, is that we externalize our minds. And we do it with spoken language, similar to animal communication in the auditory domain, but we also have started at some point to encode information on artifacts and on cave walls in such a way that it persists throughout time. And the question that we are asking in our project is, when did this start and how can we model the increase in information that we have externalized in this form? So going back not only 40,000 years, as you just mentioned, but even up to 400,000 years, we have some of the first artifacts, finds from archaeological layers, which are argued to carry intentional modifications. So what we are looking at are really artifacts where you can say that the modification of a bone or some kind of surface is really intentional. It's not just a byproduct of, say, butchering, but it is really an intentional modification. And some of the earliest artifacts with such intentional modifications are maybe around 400,000 years old. There is a famous example of an elephant rib. Here you see an interpretation, a drawing from the Landesdenkmalamt in Sachsen-Anhalt. And this comes from Bilsingsleben. It's a site which is typically associated with maybe early Neanderthals, maybe whatever came before Neanderthals, Homo heidelbergensis, and it's around 370,000 years old. In this case, the scientists who have studied these artifacts, and in particular this artifact, they argue that the patterns you see on the surface, which were engraved by some kind of stone tool, they must be intentional. You wouldn't get such a pattern if you would just butcher this elephant. Another maybe also controversial example is even older. There was an excavation back in the late 19th century by Eugène Dubois. He was a Dutch explorer in Indonesia, in Java, and he excavated some of the first Homo erectus fossils. In fact, the holotype of Homo erectus. So the fossils which in the end were used to define the species Homo erectus. And in the same site, he also found this shell. It ended up in a drawer in the museum. And then later on, people took it out of the drawer and analyzed it. And they argued that the engravings you see on this shell are again likely intentional engravings, not just a byproduct of scraping the muscle of the shell. As you can imagine, such artifacts are fairly controversial also because they're just very, very singular examples in a sea of basically nothingness at this time depth. Now, things pick up when we have arguably the development of modern humans, so Homo sapiens, in Africa, especially in southern Africa. So we have sites like Blombos Cave and Deep Kloof Rock Shelter and others such as Sibudu. And here we start to have whole collections of stone artifacts, ochre pieces like the piece you see here in the upper left corner, which are argued to again carry modifications which are to some extent intentional. In the case of Deep Kloof, I think this is not debated at all, because when you look at these eggshells, these ostrich eggshells, you see that these patterns, they are not just, the byproduct of some ancillary process, but they are really letter-shaped patterns, different kinds of patterns from different kinds of eggshells. So I think these are some of the earliest, more systematic examples which are accepted, at least in the archaeological community, of modifications of surfaces which are intentional. Right. So this is around 70,000 years ago, let's say 60,000 years ago. Around 50,000 years ago, Homo sapiens, modern humans, spread from Eastern Africa. Nowadays, you might know that there is this Pan-African evolutionary scenario. We also now have Jebel Irhoud in modern-day Morocco, where we have a fossil that is argued to look very modern in terms of its morphology. And we also have fossils from Southern Africa. So nowadays, there is a bit of a shift towards a Pan-African evolution of Homo sapiens. But in any case, Homo sapiens must have moved into the peninsula of Saudi Arabia, into the Levant, and maybe also through the Strait of Bab el-Mandeb into this peninsula and then into Europe at around 50,000 years ago. So some of the earliest uncontroversial sites we have in Europe of arguably modern human origin, Homo sapiens origin, are maybe around 45,000 years ago. And this is the period which in archaeology, or the technocomplex, which is called Aurignacian, according to Aurignac in France. The Aurignacian is already fairly widespread, around 45 to 30,000 years ago. We have different sites all over Europe which have this technocomplex of the Aurignacian technology in the layers. The data that I will show you today, or that the analyses that I will show you today are mainly based on, are from a much more circumscribed area, namely the Swabian Aurignacian. This goes back to me being a postdoc in Tübingen and starting to work with Eva Dudkiewicz. She has written her PhD thesis in particular on the Swabian Aurignacian and the artifacts which were found there. So these are essentially 4 caves: Vogelherd, Hohensteinstadel, Geisenklösterle, and Hohlefels. And the caves in the Achtal are fairly close together. So Geisenklösterle and Hohlefels are very close together, maybe 1 kilometer apart from one another. And the other 2 caves, Vogelherd and Hohensteinstadel, are also very close. And the distance between these valleys is, I think, around 60 kilometers, so maybe 2 long hikes for hunter-gatherers. So this is a fairly well circumscribed area where we have the Aurignacian technocomplex and where we can even tell that there was a connection between the different caves, because there are refittings between the different caves of stone tools. So we can tell that very likely the same people were in the caves at relatively similar times. Right, these people lived as hunters and gatherers. Just to give you a rough idea of the Aurignacian flora and fauna, we had reindeer being present there, so it was a steppe environment. We had wild horses. We still had some mammoths at this time depth, and others such as bison, steppe bison, and also dangerous animals like cave lions lived still in the area, and also cave bears. So these Aurignacian hunter-gatherers, they lived in these caves, they dwelled in these caves or in front of the caves in their respective tents, and they lived from what this environment would support them with. At this time, we now find hundreds of artifacts, tools, but also what are called symbolic artifacts, like this little figurine of a couple centimeters in size, which is a mammoth figurine. And these figurines and also the tools tend to carry, or in many cases carry, sequences of signs such as crosses or dots, and in some rare cases also combinations of different sign types. And yeah, we'll get into this in a little bit more detail later on. So overall, looking over the time, over a timeline, what we find is that early on in human evolution, when we have hominins like Neanderthals and Homo erectus, Homo heidelbergensis, roaming the landscapes of Africa and Eurasia and Southeast Asia, we have some, but rather few finds where we would say these are artifacts which carry intentional markings. It becomes more pronounced with the Middle Stone Age in Africa, around 100,000 years ago, and this is likely due to modern humans evolving, or modern humans, Homo sapiens, are typically associated with these technocomplexes. We also have some finds coming up now in Asia and Southeast Asia from this time period. We then have the Middle Paleolithic in Europe. This is typically associated with Neanderthals. There we already, in our database, have around 50 artifacts. So there is already something going on in the Neanderthal world. But then with the later Stone Age in Africa and the Upper Paleolithic in Europe, when humans move into the Levant and then into Europe, we have a real explosion of artifacts of this type with engravings. And the interesting thing is that right from the beginning, when modern humans come into Europe, they seem to carry with them these mobile artifacts with markings, like in the case of the Swabian Aurignacian. And then, of course, over tens of thousands of years later on, we have a further development towards the Gravettian, Magdalenian, and then the Mesolithic and the Neolithic time period. Right, so in this talk, I would like to show you our database that we're building on such artifacts, the SignBase team, and the way we work. And then I want to show you some analyses which are specific to the Swabian Aurignacian, because there we already have the data due to the PhD of Eva Dudkiewicz and due to the fact that we have now published the data openly online, so we can use these data for analyses. And we have used them to study the statistical properties of these sign sequences we find, in particular in the Swabian Jura. Right, so the SignBase team, that's Eva Dudkiewicz and myself as the PI. So I'm the PI of the Evolution of Visual Information Encoding ERC grant, as you said. And Eva is the archaeologist in the team. She is employed at the museum in Berlin. And then we have student helpers, Marie-Louise Hahn, who helps us with the database, and Sepio Lee, who helps us with programming, and Carla Olave Rodriguez. She is the PhD student in the eVine project. So we have published the first version of the database back in 2020. And in this version, we had 531 artifacts from all over Europe. In this case, we gave some meta information here. You can see it. It's a little bit small. And we gave sign type coding. So we said, okay, on this artifact, we have crosses, or on this artifact, we have dots, or we have lines. So we just said what type of sign we have identified there on these artifacts. In the new version of the database, so we have published 260 artifacts from the Swabian Aurignacian as part of the second version. Here we have somewhat more meta information, and we also have sign type encodings. Now this is maybe a little bit small, so I will show you in the original database. So here we have what is called the adorant. So this is an ivory plaquette. Here you see the size of it, so around 4 centimeters to 1.5 centimeters and 5 millimeters thick is this plaquette. And we have all kinds of meta information in the database, the dating, the species, and the material that this comes from. So this is made from mammoth ivory, the type of object, some literature references, and then here we have what we call sign codings according to our syntax. So we have defined different sign types, for example, a notch, as you see it applied to the side of it. So these are deep incisions which are cut into the sides of this plaquette. These would be, in a sense, iconically represented here by a V shape. And then we say, okay, if we have a certain sequence like here, we encode this as a sequence in our syntax. If we have a sequence on a different part of an object, then we have a lower underscore here to say, okay, now we have a different sequence. And then we have here these dots, which form certain numbers. So here we have the dots. So this is the way we encode what we see on these artifacts, or what Eva Dudkiewicz mainly sees on these artifacts, because she is the expert for the archaeological part of this project. If there are sequences which are non-linear, then we also encode this by using parentheses and so on. So we try to encode as much information as possible so we can later retrieve it also in our analyses. Right, is this clear up to here? Are there any questions up to this point? It feels a little bit weird just to talk and not to know if people are still there, actually.
Yeah, I have one question. Do you also have photographs and 3D models of the actual objects in the database?
We have, I will get to this, we have high resolution photographs of the artifacts that we study ourselves in the museums. Actually, for the data from the Swabian Aurignacian that I'm showing today, all of the high resolution photographs have been published as part of Eva's PhD thesis, so they are printed. But yeah, we in the next version of the database, we want to include also high resolution pictures and what we call 2.5D models. I will show you in a second what this looks like, what this means.
Cool. Yeah, just go on. I think we should have questions later.
Yeah, okay. Right, so here are these examples. This is the same example that I just showed you. Here's the example of this mammoth figurine, which is also a so-called symbolic artifact with different kinds of sequences. So when we think that certain sign types overlap, we also encode this here by parentheses. So this is a cross, but then there is another line in a sense attached to it. So we encode this by saying that we have a line and a cross, but then they overlap to some extent. I mean, as you can imagine, people can disagree on what exactly to encode here. But I actually think from my analyses that for basic statistical properties, the encoding differences do not matter that much, as long as we stick with certain very, very basic statistical properties. Now, what gets a lot of attention in this material are these symbolic artifacts, but then there are hundreds of tools, other mobile artifacts, like this here is a lisoire. So this was used to work with animal hides, to flatten them, to stretch them out so you can make clothes of them. So this is a tool, and on these tools we often also find sequences, for example, of crosses. This also here is a lissoir. Here you even see different kinds of signs which are also applied in different kinds of ways. So we have notches which are applied in one way and then in another way and then again in a different direction. So there seems to be something systematic going on here.
I have a small question.
Yes.
Am I right to understand that these sequences you are encoding, they are sort of beats where the ordering is unclear? Yes, you can say that there is 10 crosses and then 5 crosses, but each beat separated by sort of the horizontal line is you can reorder it in
Yes, that's exactly right. Yes. Mm-hmm. So the ordering in between the underscore is meaningful unless we have these unless we have square brackets, actually, then it means that it's just like a visual field that is filled. But the ordering of, like, say, the ordering here is meaningful, right? Because here we have an ordering of crosses. But the underscore means that we don't really know. I mean, this is fairly arbitrary, right? How we proceed. Of course, we also don't know left and right, up and down. You know, you don't know how these sequences were applied. Yes, so this is exactly right what you're saying. Yes. Right. So here's I have a little example video of how we use our database. Made a little video. So we have an online interface. This is a Django app that we implemented. So we can, when we are at the museum, in this case, I use this 3D model from online. This is not our 3D model. To illustrate it, we would enter this information. And then, well, there's automatically checking of whether the information adheres to certain standards. So in the museum, on the original, we would look at this original and then decide what kind of sign types we see here. So here we think we see 3 crosses and then 3 notches. And this relates to the point of your question. We now put an underscore and say, okay, there's another sequence, in this case, I think of 6 dots or 6 cupules. So we make an underscore, and yeah, we cannot really say that what comes after the underscore is necessarily directly connected. So if we go to a different part of the object, now we have another underscore and then 4 crosses. So this is how we would work at the museum. Actually, this works pretty well. I'm quite surprised so far. We always had good internet connection, so we could directly work in the database. There are many things that can go wrong, but this is a fairly reasonable workflow, actually, it turned out. Right, so yeah, we already visited probably around 10 museums at this point. One of them, for instance, the Natural History Museum in Vienna. And we also put little YouTube videos online of our visits. If you're interested, you can watch these. There is one on Vienna, and there are other ones on other museums in Germany. Right now, last week, I came back from Les Essais de Taillac. This is in the Dordogne in France. This is probably one of the most important museums there. So we will also upload a little video where you can see what we did at this museum. Now, what this looks like, I also have a little video here. So this is the microscope, a Hyrox microscope that Eva uses. This is a pebble artifact with a line on it and different lines that cross this line. So Eva is able to now scan this artifact. You can see it here now on the laptop. And she takes high resolution pictures. And then you can also produce what we call 2.5D model of this. Let's go back to the slideshow. So this is what it looks like. So here you see the high resolution picture. This is an artifact from Vychy Skala in the Czech Republic. of a somewhat later period than the period that I will talk about today. So this is Upper Paleolithic Magdalenian. So the Aurignacian is around 43,000 or 40,000 to, well, in the Swabian Aurignacian, 43,000, I think, to 35,000 or so, roughly dated. The Magdalenian is actually much later, so this is already around 15,000 or so. So it's actually, the Magdalenian is kind of as far away from the Aurignacian as it is from us, right? So that's also something to keep in mind. So that's a much later time period. So here you see the higher resolution picture. And here we then have a 2.5D model. So you cannot really turn it around in all directions, but you have a model of the surface that can be generated with the data of this microscope. Here's another really interesting example that we looked at. This is an eagle bone from Austria in this case. And what we noticed is that the lines here, they mostly add up to numbers around, I think, 12 to 15. And you might know that often it is argued that such artifacts were used to count moon phases. So I think once we have enough artifacts, we can maybe start to actually test at least the connection between certain artifact types and certain numbers, so certain distributions of numbers. If you can then make a strong argument that this was really used for counting moon phases is a different issue, but I think about this more statistically. Can we really prove that there was a deliberate choice of certain numbers of signs that you find on certain artifacts? Right, so in these analyses, so the background to our analyses is that people always ask, what is the function of these signs? And then, of course, you can come up with all kinds of ideas. Like, for instance, I just said moon calendars. In some cases, these artifacts probably have signs on them, deliberate modifications, which are to some extent iconic. So in the case of cave lions, for instance, which lived in the Swabian Aurignacian still, it is reasonable to assume, apparently from the biological perspective, that we might have seen certain patterns on their fur 40,000 years ago. So when you think about a lion nowadays, you don't think about dots on their fur, but it is not, I think, or that's what I understand, it's not unreasonable to assume that maybe they had certain fur patterns like these dot patterns on their fur. So maybe what we see on some of the figurines, which are more realistic, is basically iconic. So representing something which people actually saw. The interesting thing is that you also find these dots on artifacts which are not realistic depictions of certain animals like lions. You also have artifacts. I mean, this here is maybe not so impressive, but there are different artifacts from this area where you can see that we have a mix of humans and cave lions. So the most famous find is from Hohenstein-Stadel, the so-called lion human. And in this case, it's really clear it's a statue made of mammoth ivory of around 30 centimeters of height, which is a mix of a lion in terms of its head and its head features and the way it stands upright. These are the features of a human. So it's a mix of two types of species, humans and lions. And even on these artifacts, we find dots. So in a sense, you can maybe argue that we have an iconic character of these signs, but there seems to be maybe some kind of transition into symbolism as well, into a more abstract idea behind why you would apply certain signs to certain objects. In the case of the so-called Adorant from Geisenklösterle, you can even argue that these dots are now somewhat abstract because they're not directly associated with this figurine. And this figurine here is also, as it is argued by the archaeologists, a mix of human and lion. So we have a tail here indicated, but the way this individual lies or stands upright has certain human features. In this case, we have the dots on the backside, and they are abstracted away from this figurine. So yeah, you seem to, you kind of get a feeling for how maybe iconic signs started to become more symbolic over time. And in this case, we can also argue that we have certain numbers of dots here, which are again, I think, in between 11 and 13. And there is even more space on this plaquette. So they could have, if they wanted to, they could have applied more of these dots, but they didn't. Now, for some artifacts, not from the Swabian Aurignacian, but from France and now also from Poland, it is argued that the patterns we find really suspiciously look like moon analemma that you see if you observe the moon in a certain place over time. So this is here, these are photographs taken in Budapest in 2020 over time. Over, I think this is then 1 moon month or 1 moon phase from full moon to new moon. And in some cases, like in a plaquette from Abri Blanchard, we actually visited Abri Blanchard when we were in France last week. In the case of this plaquette, it has long been argued that it really looks like the analemma you would re-infer what it would have looked like in this place back in the Paleolithic. Now there is a newer find also from Poland where there is also this analemma shape, which is argued to look like what you would expect at this altitude and longitude when you look at the moon over time. So this is also around 40,000 years old, a similar time frame Aurignacian as the data we have from the Swabian Aurignacian. So yeah, there are these different hypotheses, and in fact, it's very unlikely that all of these artifacts are explained by the same kind of hypothesis. But I just want to show you that there are these different types of hypotheses. Many people also associate these with message sticks, as we still have them in historical times in Australia, for instance. And when you look at some examples of message sticks from Australia, then you really do get the impression that they look very similar and seem to have very similar properties to some of the artifacts we find, for instance, also in the Swabian Aurignacian. Most recently, there was an article which even argued that we are looking at a type of proto-writing system. The argument here is that we are looking at phenological calendars, so it's calendars which are associated with particular animal species, and the numbers associated with these species are supposed to tell us something about the times when these species would migrate. And so when you would be able to maybe hunt them more easily. So it's argued in this paper that it's a combination of, in a sense, iconic representations of animals, maybe also with some symbolic character and numbers, which then tell us something useful about the migration trends back in these days, which are useful for hunter-gatherers. Now, Eva and we said, okay, there are all of these hypotheses, but let us try to take a step back and ask a somewhat more fundamental question, namely, what are the basic statistical properties of these sign sequences in comparison to other types of sequences? So we use, in this study that I show you here, the Swabian Aurignacian material. So we have 260 artifacts with markings, and we compare the sign sequences we have encoded with sign sequences encoded by experts on early Sumerian cuneiform. So there is a large database, CDLI, for proto-cuneiform writing, or proto-cuneiform, I should say. Like here, the Uruk 5 period is one of the earliest periods of proto-cuneiform. Here we have tablets with engravings with a reed stylus or impressions of a reed stylus, which are argued to represent certain numbers and certain commodities. And then we also would like to compare this to a sample of modern day written languages. The way we do this is we have this corpus of Aurignacian finds. There is quite a bit of pre-processing that needs to be done in order to make these different kinds of corpora comparable and the analyses reasonable. So in the Aurignacian case, we take our sequences and we remove the parts of the syntax which are not relevant for the sequences. We then, for instance, also shuffle the sequences according to the underscores, so that we know that the results we get are not driven by the ordering of the sign strings, but they're driven by just the sequences where the ordering matters. In the case of proto-cuneiform, we have to use sign lists. So what you can see here are essentially names for signs that the experts have given to these signs. So for instance, these vertical indents or impressions with a reed stylus, they are called N14. So this hole here is associated with the sign type N14. This is supposed to be maybe the number 10 or maybe the number 6. And then we have sideways impressions of the reed stylus, which are associated with N1. And then we have other types of signs, like you can see here, or here, or here, which would then be called, in this case here, for instance, it would be called Udu. So this allegedly stands for sheep, so a commodity. And so we need to use these sign sequences, which we have in their transliteration, to also compute certain statistics over them. And then we use a sample of modern day written languages, which I have developed as a postdoc in Zurich, together with Tanja Samardzic, of overall 90 different languages from all around the world and 15 different writing systems, and also different text types, so we can be sure that we have some relatively broad representation of modern day writing and writing systems.
May I ask a question?
Yes, of course.
So you said, like, sort of in a side sense, in sequence where sequence matters for your underscore system. So obviously the encoders, like the database curators who put the sequence into the database from the object, they follow modern day convention of the Gestalt law that X's that are closer together form a sequence. But you don't know if that is the same convention for Paleolithic humans. Maybe, like, to give you an example, on the mammoth, you have X's that are symmetrically on the bilateral symmetry of the body. So they're far apart. If you look from the bottom, there's these 4 axes left and 4 axes right. But, you know, according to some other rule, you cannot really separate them. Like, if the problem is, like, in the database, you have a linear sequence, while on the animal, there's clearly minimum like a 2D kind of thing going on. So how do you sort of like how is that not biasing your statistical analysis? That's a question.
I'm not sure I fully understand. I mean, what?
So you enter the X's, like, for example, the X's on the lower back here. Okay.
Yeah.
So there's like 6 axes in sequence, but to see that as one object, to see that sequence as one object, as a sequence, is sort of like following the Gestalt law that objects that are closer together sort of like are more easily combined in the head of the human. But, you know, actually the Gestalt law was sort of like codified in the 1920s, approximately the same time where we came up with modern sort of like typography. And so now people follow these rules and we have completely internalized this. But maybe the Paleolithic humans had completely different rules and thought the first X on the sequence on the right and the first X on the sequence on the left are symbolically connected, the second ones, and so on. So you cannot really separate the 2 sequences on both sides of the body. So in some sense, it makes sense to sort of write it in your database, but you lose a huge amount of relationality that on your flat Uruk tablets is still present. Like if that's 2-dimensional, you still have the whole tablet, while the mammoth, because it's folded around, you put it in a linear sequence, and now you compare your linearization of your sequence with some statistics of another artifact where there is clearly a two-dimensional thing going on?
So, I mean, in the case of the Uruk tablets, it's, you know, the problem with the earliest Uruk tablets is that it's also not clear that people back then followed certain rules of like putting certain sequences in certain places on the tablet. I mean, in the later tablets, you have these rules which seem to be adhered to, that you, if you hold it in the left hand, you start on the left side of the tablet and then you go right. But you know, I think in the very earliest cases of Uruk 5, you also cannot say with 100% certainty that people would adhere to such laws. So in this sense, this is similar to the issue we have in the Paleolithic. Now, I mean, I admit that, you know, you can come up with, I mean, you can potentially come up with ideas of how Paleolithic humans would have connected signs on a three-dimensional surface, right? In theory, you can do that. I think it's not stretching it too far to say that humans in the Paleolithic were able to perceive linearity. I mean, I don't know. I don't even know how to test this, right? Because we only have modern humans to test it. But yeah, I mean, the way we encode it, you could still, you know, I mean, the way we analyze it now, so what I'm presenting you here is that we assume that the ordering in the sequences which are kind of linear on the object is meaningful, so that we have a certain order of crosses. And all the other orderings are, in a sense, arbitrary. You could also use our encoding and say, well, everything is arbitrary. So you could just randomly scramble each sign. You could even split up the signs into individual parts. You could say, you know, a cross is not a cross, but it's a line like this and a line like this, and then split it up and then reshuffle it and see what your result is for our statistics, right? So I think with our encoding, you can still do these analyses, but I think you would stretch it a little bit far if you would argue that the people of the Paleolithic had like linear combinations. I mean, if you argue that, say, you know, this cross is connected to this cross and this cross is connected to this cross, and I mean, then you're, in a sense, you still argue that there is a linear way that they would have read it, but not in a geometric linearity like we see it on the object. I mean, that's possible. I mean, it's theoretically possible, but you know, I think that would stretch it a little bit far. I don't know. That's my personal, yeah.
Yeah, I would love to sort of like get back to this in the discussion later. So there's one, maybe to explain where I'm coming from here. So
yes.
We're talking about an era in art history, or art, the story of art, because there is no history at that point, nobody writes, where we're very close to the summit of what's possible. Like anybody who's ever seen Shelby Cave, about 99% of all art coming later is worse. And that mammoth, like right in front of our eyes, is probably in that category. Like the whole thing, probably it's not just visual, it's haptic, so you can touch it.
Yes.
It is unbelievably accurate if you compare it to an actual mammoth. You can probably feel things you can't even see. And then these axes are not arbitrary whatsoever. They're, to me, they seem to be really good places to put a spear, for example, and make the animal die quicker. And so that means that is like where my intuition comes from, that these 2 points on two sides may actually be closer related than sort of like the sequence actually. You see, so, but obviously we don't know. We don't know what this all means. But the fact that they are doing this dot game that you just said which is like, oh, they did have an idea about, that this is something special. Obviously, they stared long enough at it that they had an idea that probably there's some kind of rule behind it. Now we know it's von Neumann patterns. You can actually calculate these dots, where they sit, and so on. And there is examples that are similar. Like, for example, the Baidarka boats, they are so fluid dynamically awesome 12,000 years ago that people took till the 1930s to get to that point with ship hulls. And the answer is because they actually sort of like go on ocean currents where there's dinoflagellates, so you can actually see the turbulence. And obviously, if somebody is rowing beside you on a boat that is more efficient, you copy that pattern on your own. And so that kind of stuff is sort of something which I think is sort of quite interesting, that we're thinking the summit of human evolution is sort of sign systems and writing and like all that kind of stuff, while we're obviously dealing with a time when the brain was almost the same size. People cooked, they had a lot of time to chat. And so there is obviously the sort of like brain power is used for something else. And the question is what? And so that is sort of something which I find quite interesting. And then if you compare it to Uruk, there's a similar thing going on. Like in Uruk, and I'm by no means a specialist, I'm an art historian. This is only like from other people talking. There seems to be a sort of evolution of numeracy, which goes from small numbers to more numbers. And, sort of first you have 1, 2, 3, 4, 5, and then you got your 12, which is the parts of fingers. And then there is more sophisticated stuff. And at some point you end up with something that looks like an Excel table and is really well designed as an Excel table. Like, I would love if students could do the same thing when they design a data frame. And so that is sort of something where there is this kind of like really interesting thing that we got all these like research on iconicity, on three-dimensional form, on haptics, on performance, because this has to do with like how we move. And then there seems to be a completely separate kind of stream of research, which is linguistics and sign systems. And the question is like, how do we bring this together in a sense, right?
Yeah. Yes, and I think they are connected actually. Yes. I think they are connected, but to go back to your original point, I mean, in theory, what I would love to do is to just have 3D models of these artifacts, so that, I mean, we try to reduce the information as few as possible, right? But in some sense, we have to take decisions on how to code things and how to put the meta information into the database. So yes, we have to. There are some decisions which are to some extent arbitrary and influenced by our view on things. All right. Yeah, thank you for the input. Okay, so now if we accept that we have these sequences of signs in terms of modern day writing and in terms of Uruk material and in terms of the Paleolithic, then we can compute basic statistical properties, type of properties that I have worked with quite a lot as a quantitative linguist, as somebody who is interested in the entropy of languages. These properties that we are looking at are typically properties like the entropy and the entropy rate of these sequences. So in a sense, a measure of how much repetitiveness there is in the sequences and how much surprisal there is in the sequences. We also then have the repetition rate, which is a direct measure of how many adjacent repetitions of the same signs we have. And we have a simple baseline measure of the type token ratio. So how many different types do we have in comparison to or in relation to the length of a sequence, the tokens. And so we basically have 4-dimensional vectors which represent each of these sequences that come from an artifact of the Paleolithic or an Uruk tablet or a modern day text or part of a text. And then we can put them into, in a sense, this 4-dimensional or 2 times 2-dimensional space. And when you look at these examples here, you can already see that there is a certain clustering of modern day languages towards higher entropies and towards lower repetition rates in comparison to the other material that comes from earlier time periods. What we then do in the next step instead of just saying we just visually look at these plots and say, okay, they are different. We also do classification. So I trained classification models. I used k-nearest neighbors as a very simple and efficient classification algorithm. And then I also trained feed-forward neural networks, or multi-layer perceptrons of different depths. So this is one of the more complex ones that still runs in reasonable time with this data. I mean, it's also not a lot of data, so it's only a couple thousand sequences. So you probably cannot really use much bigger models that need more training data. So here you see a multi-layer perceptron. And the idea here is that we have as input these feature values, so a 4-dimensional vector of feature values for each artifact. And then the model, the classification algorithm, needs to tell us, is this Aurignacian, or is it Uruk 5, or is it modern day writing? So we always have this pairwise comparison. Do we go in one direction or in another? And then we can train the model with a test set and a training set, and see how well the model performs. Right, so the results here are that, as you already saw in the plot before, if we now plot the entropy rate and the entropy on the one hand, and repetition rates and type token ratios for these different corpora, you can see, and this is something that really surprised me, you can see that the Aurignacian material and the Uruk 5 proto-cuneiform material are very similar in terms of these statistical features. So they have low entropy and entropy rate, and they have high repetition rates both, whereas in the later periods of proto-cuneiform, where we also then start to have more, as you pointed out before, we have more different number signs, and we also have more different signs for commodities and more complex sequences. We can see how the Uruk material moves towards higher entropies and lower repetition rates. And when we compare this to modern day languages, so the text data diversity sample, that's the modern day languages, then we can see that modern day writing systems around the world tend to have high entropy and very low repetition rates. In fact, the repetition rate, so the adjacent repetition of signs, is probably one of the best features to cluster and to classify sequences into either modern day writing or something else, because modern day writing systems have this avoidance of repetitions of adjacent signs. There are examples, like in German, you can repeat maybe 3 consonants according to the Neue Rechtschreibung. But in general, there is a strong avoidance of repeating the same kinds of signs. And I think this is directly connected to spoken language, because in spoken language, we also don't repeat, say, phonemes or morphemes or words or whatever kind of structure you take. We don't tend to repeat them in adjacency. In theory, you could. So I could speak by repeating B, 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 A. There is even an argument in the language evolution literature, because it was argued that Neanderthals, cannot pronounce the same range of phonemes. But then some people argued, well, in order to have spoken language, you would only have to have, in theory, like maybe 2 different phonemes. With 2 different phonemes, you can encode all the information you want. But as a matter of fact, in actual spoken languages, and I think also in sign languages, you don't have a system where you repeat the same kind of phonemes or morphemes or words. You have a system which has a high entropy, in the sense that the predictability of the next element is relatively low. There are no long repetitions of the same or similar sequences. What also surprised me, and this is related to this observation, is that, in fact, the multi-layer perceptrons, they perform the best. So in a sense, deep feed-forward neural networks, they are really good at distinguishing between writing and other kinds of sequences. That's also something I've shown in another paper back in 2023. You can, with high accuracy, tease apart writing and non-writing using multi-layer perceptrons and these statistical features. And that is doable for Aurignacian and modern day languages, and it also works really well for Aurignacian and later cuneiform periods. But for Aurignacian and the earliest cuneiform of the Uruk 5 period, you are basically at around the random baseline. So you're not able to distinguish with such a neural network between Aurignacian sign sequences and the earliest proto-cuneiform sign sequences. Now, what I also wanted to know is whether the usage of these signs on certain artifacts, so particularly for the Aurignacian, if they're used systematically with certain object types, if we can predict when we have higher or lower information density on the artifacts. And so we have multiple regression models where we predict the entropy rate as a feature. So the density of information on an artifact we predict by the artifact type. So is it an anthropomorph figurine? Is it a zoomorph figurine? Is it a tube or a flute? Is it a personal ornament? Is it a tool? And other kinds of object types. We look at the volume as a predictor. So you could imagine that bigger artifacts have a bigger volume. So you could, in theory, apply more information. The age of the artifact. So here we have artifacts which are around 43,000 to 35,000 years old. So you still have a range of around 10,000 years. So you could imagine that, something has changed over time. Maybe the earlier artifacts have less information and the later artifacts have more information. And then also preservation. So is an artifact complete or fragmented? You can imagine that if we have a fragmented artifact, which is often the case, it cannot carry as much information as the original artifact. So maybe a complete artifact would carry more information. So we put all of these different features as predictors into a model. And we wanted to find out if any of these are significant predictors. What turns out to be the case is that the type of object is really the only feature or the only predictor that predicts significantly the information density you have in terms of sign sequences on an artifact. So anthropomorph figurines and zoomorph figurines tend to have sequences with relatively high information encoding potential. Tools have sequences with lower information encoding potential, and this is a significant effect. All the other predictors are not really significant. So even the volume, the state of preservation, they have the right sign. So if it's complete, it tends to have higher information encoding potential, but the effect is not significant in this study. Also, something I have started to look into, but I didn't really do the statistics on this, but even from looking at the distributions, it seems pretty clear. It seems clear that for certain object types, certain signs were chosen and others avoided. So for instance, on anthropomorph figurines and on anthropomorph figurines, we don't have crosses. So we have several anthropomorph figurines and they have relatively big surfaces, and we have many crosses on all of these artifacts. So we have hundreds of crosses on these artifacts, but there is not a single cross on an anthropomorph figurine. So anthropomorph figurines seem to have been avoided when in terms of applying crosses. The other way around, we don't find dots on tools. We find many different sign types on tools. We also find crosses in tools and notches. I mean, notches are all over the place, but we don't find any dots on tools. And there is absolutely no straightforward reason why that would be the case. On these tools, you can apply dots just like you can apply crosses or lines. There is no material reason not to do it. But the ivory carvers back in these days, they have avoided to apply dots to tools. So yeah, some signs are used all over the place in all kinds of objects, but some sign types are actually very selectively used for certain object types. Right, so this is, here I get to the conclusions. It is really astonishing, and it was really astonishing to me that the Aurignacian sign sequences, they really perfectly overlap in terms of their statistical properties with the earliest Uruk 5 proto-cuneiform. The later cuneiform periods are significantly different from them, and the writing systems of nowadays are significantly different from them. But these earliest tablets with arguably kind of numerical ideographic signs on them, they are statistically basically indistinguishable from the Aurignacian sequences. And this was really surprising to me, because I would have thought that we have the Aurignacian, which is 40,000 years old. We have proto-cuneiform, which is around 5,000 years old. I would have expected that the earliest proto-cuneiform is much closer to later proto-cuneiform and to modern day writing, just in terms of the time. But statistically speaking, in terms of the information encoding properties, the Aurignacian sign sequences already have this information potential that the earliest proto-cuneiform tablets have. But from then on, then we have a very, very fast and very quick explosion of different signs and of information encoding potential. Certain object types were selected by these people to carry more information dense sequences. This is supported by our statistical model. So there was a certain selection that was applied. And certain sign types, as I said, are selectively applied to certain object types and not to others. So this is why I argue it's a sign system. There is to some extent a systematic usage. So I think the term sign system is justified already for these Aurignacian sequences. They are, however, very, very different from anything we see statistically later on in terms of proto-writing or writing. Now, one major difference, I've mentioned it, is that statistically speaking, and in terms of information encoding potential, nothing really seems to have changed in the Aurignacian over the course of around 10,000 years. So the people of the Swabian Aurignacian were there in these caves for around 10,000 years. And their sign system seems to have been stable for these 10,000 years, at least in terms of the measures that we have applied here. But then at some point, they just vanish. So we have some systems in the later period, or some signs in the later period of the Gravettian, but it's much less. And towards the last glacial maximum, what happens is that the Swabian Aurignacian becomes uninhabitable because it's too cold. The glaciers of the Alps would be able to descend further down, and then would have been too cold to live in this environment. So the people of the Aurignacian and the Swabian, after 10,000 years of living there, they moved away, very likely towards Southern Europe or maybe Eastern Europe, into more southern areas where it was warmer. And that's also the time period then when we have the Magdalenian and the Solothurn developing of some of the famous cave paintings in Lascaux, for instance. And then the people come back also to the Swabian Aurignacian later on, 20,000 years later. So this sign system was very stable, and then it just vanished from the face of the earth. In the case of proto-cuneiform in Uruk, we have this early system, which is very similar to the Aurignacian system in terms of statistics, but then over the course of the next couple hundred years, we see an immense growth in terms of different signs, in terms of the complexity of the sequences we find on these tablets. And then we have the direct dovetailing into writing systems that also reflect the Sumerian language and other languages in the area. Thank you very much.
Super cool. Thank you very much. Yes. Yeah.
Cheers. Thank you.
I always need to say this, like people were clapping, but you can't hear it because Zoom has a way to cut it out. We're doing Namjoon Pike TV and TV, so maybe we just unshare the screen.
Oh, yes.
Okay, so as people have questions in the room, I will zoom around with the camera, so don't. The first question is Mike.
Well, I have a few.
So let's ping pong.
Yes. One thing. Basically, what I wanted to ask is basically whether you tried to compare the statistical properties of these science systems with basically random science systems. So, for example, you fit, I don't know, the probability of repetition and type token distribution, and then just do it completely randomly. Will it be the same thing or not the same thing?
If you randomize,
Mm-hmm.
That's the question. I did it in the paper. Maybe I can find it. I did it in the paper on the Swabian challenge. I don't know if I can quickly find it now on my computer, but the answer to the question is when you randomize, you get kind of a line. So for example, if we're in the entropy space, you get kind of a line or a parabola from low to high. So depending on how you randomize and the size of the inventory, you have high in entropy or low entropy.
Mm-hmm.
So you can kind of span a part of this two-dimensional space.
Mm-hmm.
You can still, I mean, in this paper, Swabian Challenge 2023, you still get a relatively good classification performance because this random parabola doesn't really overlap too strongly with, say, modern-day writing or other kinds of systems.
Mm-hmm.
Of course, you can. The problem with randomization is, I guess you can come up with all kinds of artificial systems that, I mean, it should be possible to design artificially generated sequences in such a way that you essentially span the whole space, right?
Mm-hmm.
And then, of course, you cannot distinguish them anymore from whatever is in the space systematically. But if you apply, let's say, randomization in the sense that you just say, okay, we take the same number of sign types and then we randomize, I think you still get a pretty good you still get a pretty good distinguishability with writing, for instance, because randomization will get the maximum, will give you the maximum entropy given a certain a certain number of sign types, and that will still be distinguishable from actual writing, which is not quite there.
Yeah, sure. Yeah, so to clarify, basically, as far as I understand, you have these essentially four characteristic variables at the end of the day.
Yes.
And what seems to be a good, interesting question, at least for me, is if you fix some of those variables and then randomize given the fixed value of these variables, are they all completely, do all of them contain information, or is it possible to sort of reduce it further?
Okay. So that's like a principal component analysis in a sense, right?
Yeah, in a sense.
Yeah. I haven't done it in the way that you describe it, but in this 2023 paper, I tried to see which feature by itself has the highest classification precision. And it turns out that the repetition rate has the best classification precision. And then I think the entropy rate and unigram entropy, and then TTR. So you can distinguish them. You still get, so if you take them out one by one, then the classification performance drops. So you can, so I think there is an argument that it makes sense to leave these 4 in. I mean, so the repetition rate contributes the most to the classification performance, but if you take the others out, there will still be certain misclassifications which you catch when you have the other measures in. Yeah.
Okay. And then sort of to clarify, I actually probably forgot, you probably said it. This reshuffling procedure, when you have blocks which are randomly reshuffled, does it work only for the earliest cuneiform or for later forms of cuneiform as well?
I haven't done reshuffling of cuneiform actually. I haven't done reshuffling of cuneiform. So I mean, in this case, we also didn't encode it, right? It's the experts who encoded it. And we take the transliteration as it is. We don't shuffle it. Yeah.
Because in your transcriptions, you showed these horizontal underlines in cuneiform as well, which sort of...
Yes.
Okay, but you don't...
You could make an argument that... So the question is, I mean, I mentioned this before, in later periods, the ordering of these sequences in between the underscores is meaningful because the scribes would apply these sequences in a certain syntax. In the earlier periods, in the Uruk 5, there is an argument in the literature that sometimes it's not systematic. So then maybe you could argue that you should apply shuffling as well. Yeah, I haven't done that.
Basically, I'm asking because it seems that it correlates with your output. Yes, that the first cuneiform and this old prehistoric symbolic things, what they have in common is that the order is not the order between blocks is not fixed. In the sense, it's somewhat arbitrary. While for later cuneiforms, it is.
To some extent, yes. To some extent,
so at least it feeds also into your.
Yes.
Conclusion that they have something in common, which is not
I mean, yes. So for the Aurignacian sequences in. Basically, yeah, maybe I can quickly find the plot in the GitHub. Let me just quickly. I need to share again, right? If I want to show you the plot, let me quickly share. So this is what it looks like when you compare the entropy rate, for instance. I mean, the entropy rate is actually the only measure where the ordering would actually matter, because for all the others, you get the same type token ratio, whatever the order is, and you get the same unigram entropy. So for the entropy rate, it matters. But what you can see here for the Aurignacian material, if you randomize these strings, you basically get the same result. I mean, you have a correlation of 0.99. So there is no information in the ordering of these sequences. All the information is in the individual sequence, in a sense, right? But I haven't done exactly this for Uruk 5, and maybe I should do it to see. I mean, in Uruk 5, you probably have a little bit more information in the. It could be. It's something that would be an interesting, interesting.
Thank you.
Thank you. Let me move to other side. Whoops. We got a little battery problem with our camera, so I should have moved before. Okay, I got a bunch of questions too. So what you need to know is like my PhD is in art history and classical archaeology, so functionally also art history from your perspective, I guess. So the questions I have are sort of like coming from the object and the sort of visual side, which sort of are a little follow-up to what I sort of like mentioned before. So one of the interesting things, if we think about the art at that time, is that is almost always highly performative. So in these cave paintings, if you look at papers, people have figured out like how would they actually be seen. You know, obviously you need some kind of torch, and then there is animals that seem to vanish into the wall and like all that kind of stuff. And like, how do you stand there? Like if you put the hands there where you actually put them, then you actually stand pretty close to the ball, whatever. So there's a kind of like question of how this stuff is perceived. And let me start with a simple example. You have basically four categories. You got this icons, and there we can summarize, this is probably a really small set of really highly sophisticated objects. You got your mammoth, you got your adorant with the lion's tail and the dots. There is a similar sculpture which is called the Lion Man, which is sort of the same thing without the plate. And then we got this Venus of Hohlefeld, which you also showed, like this is thing that everybody knows, the fat Venus of Willendorf in Vienna, but it's this thing which has some notches in it, which is interesting. Yeah. So the Venus of Willendorf is almost always shown with the Venus of Hohlefeld because one is stripy, the other one has all, you know, there's this sort of like ornament in the hair and stuff like that. Yeah. So haptically, they're very similar objects. But
actually, the Venus of Willendorf, this is something I didn't know, but we saw the original in Austria at the museum. Yeah. And Caroline Posch, she showed us some high-resolution pictures of it also. And in fact, the Venus of Willendorf also has signs on her hands, which you don't really see in the photographs. And the Venus or female figurine from Hohlefeld also has signs on the arm and on the hand. So there are certain similarities that you don't sometimes really see unless you look at the really high resolution pictures or object in the original.
So let me get back to those complex objects later. One interesting thing for anybody who's watching this on the web, and we don't have slides for stuff, but we mentioned these are really, really worthwhile checking out. Every human should know these things because they're so rare and so awesome and so old. Then you got these three other categories, which is calendars, and that is, I think, super convincing and really, really interesting with these sort of like moon patterns. Message sticks and proto-writing. And so the simple thing is the message sticks. And one of the interesting things is that they use notches. And so then the question is, how do you read them? And I always think like, it's like if you have a bunch of these, and you probably not sit down and like look at them, but particularly if you're actually sort of like, walking down an antelope or whatever, you can actually read them with your thumb by holding this thing in hand. And that is a completely different ballgame than, sort of like having a bunch of different visual symbols, but there's actually something going on. And that actually harks back to this thing that why does and this like the person I think who found it, the Venus of Hohlefeld with the stripes, looks like Fernando Viegas and Martin Wattenberg would find this funny from Google. They did a project called Flash Map where they mapped what are the erogenous zones on a human body by people pointing out where is that. And the person who found the Venus of Hohlefeld pointed it out. It's like, this is a sex figure. And then obviously people don't agree. But the key thing is like one thing that cannot be denied is like the areas where the stripes are things which in a homunculus manner, obviously large hands, large vulva, large certain things, small other things have to do with touch. And the same is true for this mammoth. Like, these crosses, they're not on sort of random places in the body. They're actually, if you have ever touched a mammal, there is certain things going on that don't go on in other places. And I think that is sort of something which I find quite curious, that there is a sort of like thing where in art history, we do so much in the visual realm. In linguistics, we do so much in sequence realm. Like it's almost like if you look at supercompute clusters, biology is not any different. We either do sequence alignment or we do visual similarity of like sort of like two-dimensional visual matrices. While human life has a lot to do with this like stuff that happens in meat space with feelings and so on in sculpture. And that is not only true, as you said, for the Venus of Willendorf. This is also true for ancient sculpture and sculpture all the way up to the 20th century. Sculptors have a very, very precise feeling of like what can be touched and so on. And now we sort of like, it almost seems like through sort of like the, you know, transformation of science being sort of like to meta, we don't touch these objects anymore. As an art historian, you cannot go to the museum and touch a sculpture. And in the same way, you probably cannot touch the originals without anybody saying, hey, you need to wear gloves or whatever. But the people who use these objects, produce these objects, probably had a very haptic sort of relationship with them. And the question is, what does that mean in terms of how do we actually represent them in our computer models? Like, how do we, like what is the actual notation that can represent that haptic dimension in a sense?
Well, for me, I'm always asking myself, okay, how can we somehow more systematically test certain hypotheses? And what you said about message sticks maybe being read more with tactile, with the fingers than with the eyes. I mean, that's an interesting point I haven't thought about. I don't know what people would say that work with message sticks in historical Australia, if that is true. That would be one way of getting some ethnographic comparison. Another way this could be potentially tested based on our data is if you have maybe some useware analysis. In a sense, you know, if you have something like a lissoir or a bone, and if there are notches, and these notches were often touched and felt, read, so to speak, in a tactile way, you should see a certain level of use on them, right? So maybe, you know, when you have a big enough corpus of these, maybe it would be possible to try and test some of these hypotheses. That could be interesting.
Yeah, that makes a lot of sense. Follow-up question in the same direction, like the fourth dimension you had, which was this proto-writing systems. On your overview picture, you ironically had a bunch of pictures of cave paintings. So they were not writing systems, but you had like different bulls from...
Yeah, so the paper by Bacon et al., they look at mobile artifacts, but they also look at cave paintings. So everything from the Upper Paleolithic in a sense, yeah.
So is that something that we can sort of like, that's a stream, like that is a sort of parallel thing, right? You got your sign systems of like crosses and notches and stuff like that, which is sort of the embellishment later in writing. But if you think about like the A being a sort of like upside down cow and the B being a house and stuff like that. So it seems like that the actual characters in the later writing system are sort of transformations of stuff that is iconic. So it's not the crosses and notches that become the writing system, but the actual mammoth or elephant would become a symbol. Obviously, they're not around at that point. But you see what I mean? So if you have something like hieroglyphs, the hieroglyphs are not sort of like simple signs, but they're actually sort of depictions of something that was actually iconic.
Yeah. Well, but so in the case of Uruk, in Uruk 5, so the earliest period, you have, I just put it into the paper, you have more than 80% signs which are argued to be numerical signs. So you have different kinds of indents with the reed stylus, and then you have additional, like say you have a vertical indent, and then you have lines through it. So abstract signs standing for different types of numbers. In the earliest period of Uruk, that's around 80% of the signs. And there are only very few iconic / symbolic signs, like Duk, which is this vessel that you have seen on the major the major example I gave. You have, I think, Udu is already there, this circle with a cross, which stands for sheep. I think it's only really a handful, literally, of iconic/symbolic signs in the earliest period. When we go to the later periods, Uruk 3, Uruk 4, we have around, I think it's 80 signs in Uruk 5, and 80% of these are number signs. When we go to Uruk 4, we have 800 signs, and I think it's exactly the inverse. Then you have 80% of signs which are commodity signs. So there are also loads of number signs, but the commodity signs representing different kinds of goods to trade, they just explode within a couple hundred years. And you can totally see how that has happened due to the economic context, right? They just needed to encode more information about the commodities they were trading. And that just led to an explosion of the signs. And once you have this explosion of signs, it then starts to become more and more likely that people will think, oh, actually, I'm starting to run out of possible signs I can still use, shapes I can still use. And that's the point where then the rebus principle seems to kick in, that you start to associate signs with certain sounds and syllables, and independent of their original meaning. And then you start to represent spoken language. So, but again, the origin, I'm not going to say that the notches and dots that we have in the Swabian Aurignacian are necessarily number signs. It's hard to prove. We are trying, right? We are trying to associate them, at least statistically, with certain numbers. But if we accept that they could be number signs, then again we would have loads of them in comparison to the iconic signs, right? You have relatively few iconic signs. You have some, but you have relatively few. So in that sense, again, it's actually very similar to what we have in early proto-cuneiform, I would argue.
And I have a bunch of system questions, actually 3. So number 1, if you think this is a system, which is very convincing, how global / Eurasian African is that system? So because obviously there's a way higher probability that they moved around than with people when they're sedentary and do agriculture. So how far did this travel? How often did it emerge? Did it emerge more than once? And then was there a standard? Like, could you walk 3,000 kilometers and somebody still sort of can understand your message stick? Is that a thing, or what do you think this is sort of like utopic?
We want to test this geographic signal of sign types being used. We have done some preliminary analyses. I think for many of the sign types, there is no geographic signal at all. Notches are just all over the place. You have them in the Levant, you have them in Europe, you have them in Africa. For other sign types like crosses maybe, or then you also have star patterns. So, a cross plus another line. I think it's more local. And one thing I noticed, there is a relatively big corpus from modern day Russia, from Siberia, of artifacts of the Gravettian period, around 35,000 years ago, 30,000 years ago. So there is a relatively famous site in Siberia. And there I looked at some of the papers, and I noticed that on the tools, you have loads of dots. So there it seems to be, a different association. In the Swabian Aurignacian, you don't have any dots on tools. There you seem to have examples of dots on tools. So there seems to be something different. So this is around 10,000 years apart, and I don't know how many thousands of kilometers, but there seem to be such local signatures and differences in how the signs were used, actually.
And then So this is sort of the geographic question, and the second and the third question is a sort of like more temporal question. Like obviously you have this sort of like pool of like, and as you say, you know, it may be different in Siberia, whatever, but like, you know, you can move around. So everybody, you could learn a dot, but then use it for something different, as you do today too, right? So there may be syncretisms and splits and divergences and whatever. Obviously, we have too little material. But now, in general, would we think that this has been forgotten completely and then reemerges, or like, let me give this one thing which, you know, we basically know when people started doing agriculture, because that's when they found sort of where the wheat grain splits off neatly. So after Göbekli Tepe, where people are still nomads and prey to animals, obviously then sort of like Uruk, that kind of, you know, this very short story, like this Fertile Crescent thing happens. And there the mythologies sort of are aware that there were people in the northwest, if I remember well, that actually still prey to animals and were not living in cities and stuff like that. So there seems to be sort of some connection there. And then the question is, from this place, like, you know, from 12,000 years ago, southern Turkey, is there a connection to all these sort of like to the world of Paleolithic sign systems? Do you think that there is sort of some uninterrupted row of at least people finding objects that have notches, or, you know, basically just re-emerge it with, as Fritz Axel would say, same form, different meaning, or same meaning, different form? So would they, is there a connection basically, or do you think it's completely forgotten and people just reinvent it basically?
Yeah, that's of course a question that is very hard to answer. So, I mean, one point right now where we have more evidence also from genetics, for instance, there was the paper by Cosimo Post and others back in 2023, I think, or 2024, where they showed that the Aurignacian people are, genetically speaking, essentially discontinued. So we today in Europe or anywhere in the world have relatively little genetically in common with the people of the Aurignacian. So there must have been a major, maybe new people from other parts of the world migrating to Europe, or the people dying out. I mean, a lot of these populations went through bottlenecks and maybe just vanished. So for the Aurignacian people that produce these signs that I showed you now, it seems like, I mean, genetically speaking, they seem to have been, well, discontinued. Whereas for later periods like the Magdalenian, so after the last glacial maximum, we have the spread of the Magdalenian culture, and the Gravettian and the Magdalenian, which comes with the spread also of the figurines, female figurines, sometimes of an abstract type. They're spread all over Europe. These people of the Magdalenian, I think, if I understood the geneticists correctly, they have more of a direct ancestry still represented today in us. So from this genetic perspective, it's possible that this was discontinued, that this was completely lost. Mm-hmm. From the perspective of our data on the signs, you know, in the Magdalenian, what we do have, we still have artifacts, and we still have artifacts on which you find crosses and dots and these sign types that you have already seen 20,000 years earlier. They still seem to change in the sense that in the Magdalenian period, there seems to be more combinatoriality of these signs. So the repetitiveness of these signs seems to go down, as far as I can tell. But is that a proof that there is a continuity? Well, not quite, because we have to distinguish between reinvention and, you know, latent solutions. So do people just independently from one another come up with these kind of sign types? Or do you have to argue that there must be some kind of continuity? Mm-hmm. But that's hard. I think it's hard to test as a hypothesis.
Okay.
Yeah.
I'm sorry. I'm an art historian. There's a third question, which also has to do with time, which is like, if we have at least a possibility that there is some kind of connection, and there is no sort of like, oh, I'm spreading dots on an object ex novo, but I have seen an object with dots, even though I'm not related with them genetically, maybe. So the other question is there a residue of that culture of working with dots and marks and notches and iconic presentation, sort of visual symbolics, that is not a writing system that is still around? And like, let me give you sort of like some thoughts on this, which is, this is like tongue-in-cheek. A lot of network scientists are from the area where linear pottery culture is from, which is the one high culture in Europe that didn't write, but they did a lot of dots and lines on pottery. And so I'm not a friend of these kind of like arguments, but the key thing is like, one thing you cannot deny is like, okay, so they put a lot of thoughts on how to put dots and lines on pottery. And the same is true for Greek geometric ceramics, and basically all over the world you find some kind of geometry and stuff. And if you think about it, like, this is not as like stupid as people have framed it, as primitive as people have framed it, as, oh, they just do geometric patterns because they can't do a realistic whatever depiction of a human body with some drapery around. But it's actually often highly sophisticated. And the notion of like putting, like, that goes back to your von Neumann patterns, right? So where you ask yourself the question, okay, you have a cat or a cat-shaped object, and so nature puts spots around them, and it's sort of an annealing process of how that happens. And if you do this by hand, if you try to sort of like not copy the cat, like, oh, it has a dot here, put the dot here, but if you put dots on a cat and it sort of feels balanced, you, without knowing the actual equation of the von Neumann sort of algorithm, you still sort of perform something like a generating mechanism. And then the question is that something that humans have evolved to be particularly good in symbolic representation, because they're particularly good in doing that sort of like simulation internally in their heads, which obviously is some kind of sophistication, which is very, very distinctly or sort of very, very pronouncedly distinct from actually writing and having a sort of like, a symbolic presentation on something that looks like something that is something completely different, right? Like the characters don't look like cat. So copying a cat, having a cat depicted using a generating mechanism that looks like a cat, way more satisfying, or writing the word cat, are sort of three different things. And my question is that middle part something we didn't look at for a very long time? Because in art history, we have been chauvinist about anything that doesn't look sort of naturalistic, like Raphael. And in linguistics, people have been chauvinistic about the fact that anything that doesn't look like a writing system. So do we miss some awesomeness in the Paleolithic and Neolithic world that we should have more respect for these people, basically?
Yeah, no, this is a very interesting point, actually. I think that's absolutely true. I think also in terms of writing, we need to think about design features of writing, like Hockett defined design features for speech. And I think some of these design features of writing are there from the Paleolithic onward, and also in something like pottery. So, we discussed linearity. I think it's a necessary condition for actual writing representing speech to be linear, because you need to order the things in some order. I mean, in theory, you could have a complicated way of ordering things on a three-dimensional surface, but somehow this needs to be known how to go from one point to another. And then again, it's some kind of linear representation. So linearity.
So do you really, but isn't there, like, people can totally imagine, like, if you think about the cognitive science of Peter Gerdenforth, that, it's much more probable that we imagine color as a field, like a coordinate system or something like that. We have place cells, like there's lots of stuff that we quote unquote imagine, which is not linear, but we may even sort of implicitly, have 8-dimensional tensors in our head. We just cannot communicate about them, but we still can operate with them in our brain. So that means not all encoding needs to be linear in a sense.
Yeah, maybe that's true. It sounds like too abstract a question for me.
Okay.
But the point about say pottery and patterns on pottery, or the point about linearity and different properties of writing and of visual information encoding. So for me, for instance, what I came to realize as part of this project is that the litmus test for writing, like the connection between, say, spoken language and sign sequences, or also hand shapes in sign language and some kind of visual system. This connection is a necessary or a sufficient condition to call something writing. But from the perspective of visual information encoding, I would say it's actually not so important, because you can encode all kinds of information without it being connected to spoken language, right? As we do in our computers in off and on states, in ones and zeros. So other features, such as linear ordering, are maybe much more important for visual information encoding than this connection to spoken language. But we always, for some reason, we focus on this connection to spoken language. And I think we should look at different kinds of features, visual properties, which are relevant for writing and for visual information encoding, which are not necessarily the sufficient condition for writing. Does this make sense? So maybe this is where, what you said about linguistics always looking at sequences and art history looking at visual patterns. I think the two do connect, and they should connect, because otherwise we won't understand how writing came about and how visual information encoding in general came about and changed over time.
Do you have another one?
Well, I have a rather stupid general question to understand the sort of the general pattern. What at this time you're talking about, what have Neanderthals already vanished, or are they still around? And is there anything at all is there any difference between humans and Neanderthals on that stage in terms of science systems and what is known about that?
Wow. Okay. It's a tough one, right? So I didn't understand the beginning of the question. If they are still around at the time of the Aurignacian, was that the first part of the question? Yeah, they are still around at the time of the Aurignacian. I mean, in general, in Europe. So the thing in the Swabian Aurignacian, and this also seems to be the case in many other places in Western Europe, like in France. We do have occupation of Neanderthals for like many, many tens of thousands of years, let's say in a cave or in an abri. Sometimes hundreds of thousands of years of material culture accruing. And then we often have a sterile layer, which, I don't know, might be worth a couple thousand years or so, if you can even estimate it. And then you have modern human layers. I mean, layers of the Aurignacian technocomplex, which isn't generally accepted to be associated with modern humans. It's not 100% clear. We have some modern humans, say in Baciukiro and in other places in Europe where we really have modern human remains. But in general, there is this, there is often this sterile layer. So in many places, there is no evidence that modern humans and Neanderthals have co-inhabited the space. But then there are some transitional industries. We just talked about it. In the case of France, it's the so-called Château Péronien. So it's an industry which was traditionally associated with modern humans. It's at this time frame of like 45,000 to 40,000 or so. But now there is this discussion, is it actually modern humans? Is it Neanderthals? Is it both? It contains, the debate is because, you know, it contains certain artifacts, like an increase in artifacts made from bone, which is not typical for Neanderthals. So there might be some places in Europe where Neanderthals and modern humans have encountered one another and also influenced one another. When we look into our database from the time period before, let's say 45,000 or 50,000 in Europe, we only have maybe a couple of dozen artifacts which are argued to have intentional markings. There is, for example, one that was discussed in a paper by Francesco Derico back in 2017 from Le Pradel. It's a hyena bone. It was found in an abri that was likely used as a hunting site. And there you have these engravings, which are somewhat irregular. So they argue that the irregularness is maybe a sign of these representing numbers, counting something. But yeah, in general, if you look at the material as a whole, there is very, very little which we can directly, very securely attribute to Neanderthals. And with modern humans coming into Europe, we suddenly have hundreds and thousands of artifacts. So it's really, really noticeable that there is a difference in terms of these artifacts.
Okay, thank you.
Yeah, I have a follow-up question to this. So I'm supposedly, according to 23andMe, 3.7% Neanderthal. If you could see this not just in my brow ridges, but in my clothing, I would at least wear pink socks and pink shoes all the time. And so that's not a small percentage. So in some sense, they must have not only had sort of like encounters that were like thousands of years apart, but they probably didn't hang out together. And in some sense, in modern societies, and what I mean with modern is literally since Uruk, because we have actual, they conquer another city, and then sort of they have the same xenophobic shit going on we have today, but then sort of like they enslave, like the guys are all dead, the women are all married, they move part here, part there, then you got two mixed cities, and then they hang out in a beer garden together and they come up with awesome shit in the same way that I can sit in a beer garden in Brooklyn and talk to somebody from Puerto Rico and come up with a cool design idea, which I wouldn't have come up with in Bavaria. So the question is, don't you think there's a possibility that the awesomeness of human culture may actually be a consequence of diversity, not of some, let's say, Homo sapiens winning against some supposedly not so valuable Neanderthal, which sounds a lot like white people winning against other people. But like, is that sort of something is that something that has ever been considered? And also given the fact that a lot of archaeological literature in the last 150 years was quite racist, is that something that has been considered in recent times, that actually the diversity and a mixture of people moving around, exchanging sign systems and stuff like that may lead to innovation. And that includes probably Homo sapiens and Neanderthals, doesn't it?
Yeah, I mean, so in archaeology right now, there is a major shift towards focusing on what Neanderthals were able to do. So yeah, traditionally there was this idea that they were brutes and so on, that has certainly shifted quite dramatically. So they have, as far as I know, but this is not my area of expertise. In a sense, you would have to talk to Eva Dudkiewicz or the geneticists. But as far as I know, what we know right now is that they have certainly encountered and co-inhabited certain spaces in the Levant, in places like Schul and Kafze. So there they have certainly encountered one another, and there's absolutely no reason to assume that they didn't, trade. They didn't, I mean, we know that they intermixed, right? So yeah, I mean, and I'm sure they have learned something from one another. I mean, that would be kind of the default hypothesis. But the thing about Neanderthals, here's the thing about Neanderthals. I talked to Eva about this also, and she said, when you look at the Swabian Aurignacian, the thing is you see that they have inhabited these caves for like tens of thousands of years, hundreds of thousands of years, and they have produced fairly consistently their style of tools, their style of artifacts. They must have had a fairly consistent lifestyle in the environment that they lived in over long periods of time. And then we have the sterile layer, at least in Central Europe, and then modern humans arrive, and we have, you know, artifacts of all kinds. We have the mammoth figurines and so on. So yeah, if you look at it, you might say, oh, how great we are and how stupid Neanderthals were. But the thing is, you know, really objectively speaking, we don't know what the end of our story is and what the future brings. So if Neanderthals have lived in their way for hundreds of thousands of years, you know, consistently and sustainably, and we are gone tomorrow because of reasons, you know, from the outside, I don't know if Neanderthals look so stupid, right? So, you know, if we take this perspective that we are so much smarter, we are kind of telling the story from the end, but we don't know the end of the story.
That's true. That's a pretty depressing way to see it, isn't it? Because like there's a way higher probability that we would extinguish ourselves in much quicker time.
We could, at least, so we don't know, you know?
Yeah. There is one question was sort of like I was sort of like submitted to me in a chat, which was coming from Yana Sachi, which was sort of like the idea that the markings on the mammoth could actually also be sort of markings that were on the actual mammoth by sort of a, you know, very venerated mammoth that was hard to kill and had wounds of spears and stuff like that, which is an interesting thing to think about. So the question is like, is that something that is in the scope of, like, obviously in your work, you focus on these sequences, but is there other work that actually sort of like lays out all the hypotheses that we, talking about hypotheses that we could have regarding these things? And one of the things that comes to my mind here is like, and so we're both German, you know what was ist was is. So it was these popular science books, which were a little bit like Cosmos with Carl Sagan for Germans. And as kids, we read them. And I remember I had the one where there was sort of like the Paleolithic, there was a mammoth with a family, and obviously the dude would actually kill the mammoth with a spear. And then there was like the woman was sort of somewhere behind. It was like this chauvinistic patriarchy picture of the 1970s family, basically. And it took them like 30 years to change that picture. And then it didn't become better because, like, you know, it was like sort of fig leafy about it. So this kind of thing of like a true visual critique, an art historical critique of these objects in the same way that the archaeological depictions of that are critiqued and need critique. Is that something you see in the literature, or is that something that still would be desiderate and, you know, sort of another postdoc you should hire, basically?
Well, yes. So I think Eva Dutkiewicz has done a very good job in her PhD thesis in discussing the different hypotheses about the potential meaning of these signs. So with regards to the Swabian Aurignacian in particular, and also more generally, so there is quite a bit of work. Of course, archaeologists are often focused on the day-to-day excavation work and the publication of the artifacts that were found. That's just the most important thing. So this kind of secondary analyses, and then even connecting it to art history and so on, that takes much less room in general. But there is quite some work on these topics and on questions of meanings of signs and hypotheses. And I think so far they have been formulated and justified mainly qualitatively. I think now there is more work, like for instance Bacon et al., where people try to use data to test hypotheses. And I think, I mean, for me personally, that's the way forward. I think many of these hypotheses can essentially be tested because we might have enough data to say, okay, you know, if we have, I would assume that we have at least 100 or 200 artifacts that represent animals. If we have the hypothesis that the marks indicate wounds, places where you would need to stab an animal in order to kill it, you can probably test this hypothesis statistically in some way. So I think that's the way forward, really.
Excellent. So we're hitting the 2-hour mark, and I will do what I do every week on Monday, which is not a week in the future, but that's like 1, 2, 3, 4, 5 days in the future. We got Laura Nelson, and Laura Nelson will speak about the topic. We're talking about the wrong error, why variance matters more than the bias in AI. We will stay with the topic of sort of quantification and culture. Christian, this was amazing. Thank you very much. This was super inspiring for me also, and I think also for Mike, and I hope we will meet in the flesh in the future.
Yes, hopefully.
Thank you.